Assalamu alaikum students. Now we're going to start our topic number 4, that is Bernoulli's equation. Now we will discuss the definition. The sum of static pressure and dynamic pressure of a fluid flowing steadily through a pipe remains constant is called Bernoulli's equation. As you know the definition for the static pressure, that it is at rest, and dynamic pressure, you know that is the pressure in the motion. So both of the pressures exerted on the fluid remains constant flowing through the pipe is called the Bernoulli's equation. As we are relating the static pressure and the dynamic pressure. The Bernoulli's equation will be given as P plus 1 over 2 rho V square plus rho GH is equal to constant, where P is the pressure, rho is the density, V is the velocity, H is the elevation of the pipe, and G is the gravitational acceleration. Here the points 1 and 2 lie on the streamline that will be shown in the picture. The fluid has the constant density. The flow is steady. For a laminar flow, you know that the flow is steady and there is no friction. So although these restrictions sound serve, the Bernoulli's equation is very useful, partly because it is very simple to use and partly because it can give great insight into the balance between the pressure, velocity and the elevation. Now we'll discuss the picture. Here you can see that the picture is of a pipe which have a narrow area on the left hand side and a wide area on the right hand side. You can see that there is the pressure P1 exerted on the left hand side with the area A1, and the fluid covering the distance is given by S1 is equal to V1 del T. The fluid flowing through this cross-sectional area is with the velocity V1. The elevation of the pipe of the narrow pipe on the left hand side is H1, and on the right hand side you can see the area is A2, that is the wider area with the pressure P2, and the distance covered by the fluid is here S2 is equal to V2 del 2 V2 del T, and the velocity of the fluid at the wider area is V2, and the elevation of the pipe at the wider area on the right hand side you can see is given by the H2. Now we are going to explain about the pipe as discussed about in the picture. Consider a non-compressible and a non-viscous non-rotational fluid that is steadily flowing through a pipe as shown in the previous picture. The portion of the pipe has a cross-sectional area A1 on the left hand side. It is horizontal there and having the elevation h1 from the reference level. The pipe shrinks and rises up at right hand side from the cross-sectional area A2 on the right hand side, as you have seen in the previous picture. I told before it is again horizontal there having the elevation h2 from the same reference level. The shaded portion at the left hand side acts as a first state system. The fluid mass m having density rho is filled in shaded portion at the left side in time t by applying the pressure P1. The fluid occupies space x1 that is shown in the picture with the S1 and moves with the velocity v1. This fluid element moves steadily and reaches at shaded portion at the right side, which is second state of the system. The fluid moving with the velocity v2 occupies space x2 that is shown with the S2 in the figure of shaded portion on the right hand side of the right hand side, but it faces the pressure P2 that is in the opposite side. Here the pressure force will be given as F1 is equal to P1A1 that performs a work done W1 on the fluid is in the shaded portion on the left hand side, and the pressure F2 is equal to P2A2 that performs the negative work done W2 on the fluid in the shaded portion on the right hand side. The work done Wg on the system by the gravity as the pipe is elevated from the reference level or the ground is associated in lifting the fluid element through the height, that will be S is equal to H2 minus H1. The change in the kinetic energy is equal to the work done according to the work energy theorem that you have studied before. Then the work energy theorem is given as W is equal to del Ke, that is work done is equal to change in kinetic energy. The whole work done is W1 plus W2 plus Wg, that is equal to the change in kinetic energy. Now here we know that we have work done. W1 is equal to F1 dot X1, W2 is equal to F2 X2, Wg is equal to Fg dot S. Then the above equation, which is given before, W1 plus W2 plus Wg is equal to change in kinetic energy. We will substitute the values F1 dot X1 plus F2 dot X2 plus Fg dot S is equal to change in kinetic energy. Removing the dot product, we get F1 x1 cos theta 1 plus F2 x2 cos theta 2 plus Fgs cos theta uh, is equal to change in kinetic energy. Here you can see from the picture that theta 1 is equal to 0 degree and theta 2 is equal to 180 degree in the 180 degree, and the theta for FGS system theta is 180 degree. Substituting these angles value, we get the values for F1. We get now using the values of F1, F2, X1, X2, Fg and S, we get F1 is equal to, we have written before, F1 is equal to B1A1, and in the picture that is shown S1, here we have written X1 is equal to V1T, F2 is equal to P2A2, and X2 is equal to, that is S2 from the picture, and it is equal to V2T. Fg will be equal to the weight of the fluid according to the gravity, that is Fg is equal to mg, and the height of the pipe will be S is equal to H2 minus H1. Substituting the values and completing the angles, we get cos theta 0 is equal to 1, cos 180 degree is equal to -1. Substituting it, we get substituting all the values, we get P1A1 into V1T plus P2A2 into V2T into -1 plus mg into H2 minus H1 with the -1. Substituting all and solving, we get P1A1 V1T minus P2A2 V2T minus mg into H2 minus H1, that is equal to the change in kinetic energy. And here I have shown with the equation A. As from the equation of continuity, we know that area into velocity A1 V1, area into velocity is a constant, so A1 V1 is equal to A2 E2. Then the second term in the equation A becomes P1 A1 V1T minus P2 A1 V1T minus mg into H2 minus H1 is equal to del Ke, that is change in kinetic energy. Taking A1 V1 common from the first term on the left hand side, we get A1 V1 into P1 minus P2 into T minus mg into H2 minus H1 is equal to change in kinetic energy. Here you can see that V1 into T is x1, so substituting the value, we get A1 x1 into P1 minus P2 bracket close minus mg into H2 minus H1, that is equal to change in kinetic energy. And we know that area into distance, A1 into x1 is the volume, so writing volume into P1 minus P2 minus mg into H1 minus mg into H2 minus H1 is equal to change in kinetic energy. Now, from this equation, solving and multiplying mg with the H2 and H1, we get volume into P1 minus P2 minus mgH2 plus mgH1 is equal to change in kinetic energy. We know that density of the fluid is rho is equal to mass over volume, and we know that volume is equal to m over rho. Then the above equation will become, substituting the value of volume, we get m over rho into P1 minus P2 minus mgH2 plus mgH1 is equal to change in kinetic energy. As we know that change in kinetic energy is equal to 1 over 2 m2 v2 square minus 1 over 2 m1 mv1 square. It means that change in kinetic energy is equal to uh, change change in kinetic energy is equal to E2 minus E1, means that kinetic energy of the second system minus the kinetic energy of the first system. Then we get m over rho into P1 minus P2 in minus mgH2 plus mgH1 is equal to half mv2 square minus half m1 v1 square. Now taking m common on the both side and cancelling it from the equation, we get after that P1 minus P2, and multiplying rho with on the both sides, we get P1 minus P2 minus rho GH2 plus rho GH1 is equal to 1 over 2 rho V2 square minus 1 over 2 rho V1 square. Now rearranging this equation for first system and second system, we get P1 plus rho GH1 plus 1 over 2 rho V1 square is equal to P2 plus rho GH2 plus 1 over 2 rho V2 square. Then this equation, we know that both these systems are equal, so this relation can be written as rho plus, that can be written as P plus rho GH plus 1 over 2 rho V, as I have told before in the definition, that is equal to constant. So this is called the Bernoullis equation. The term here P plus rho GH is called the static pressure, and because this remains there even that when V is equal to 0, and the term 1 over 2 rho V square V is 1 over 2 rho V square is called dynamic pressure. Here we have derived the Bernoullis equation. Uh, if there is any question regarding the topic, you can ask me. Hopefully, I am quite unable. I am quite able to let you understand about the Bernoullis equation. Hopefully, you will be able to understand. Thank you so much. Thank you. The end.